Right, so far we have solved a system of equations by graphing. Now we're going to get into systems of inequalities. At the end of this lesson, you'll be able to solve a system of linear inequalities by graphing. Alright, so a solution to a system of linear inequalities. If you remember, with inequalities we do lots of shading, so there's more than one right answer. So same thing with systems of linear inequalities. There are going to be all sorts of answers, not just one. So when we solve it, it's going to be all of the points that make both inequalities true. So we're going to do lots of testing, and again, I'm just going to put like an X and a Y because there's going to be all sorts of points that we're going to be dealing with. Right, we're going to jump right into examples. We're going to find the solutions to the systems of inequalities below, and then as we get through the answer, I'll try to explain kind of what's going on. All right, we've got y is greater than negative 2x plus, let's do plus 3, and then y is less than or equal to 2x minus 4. All right, so the first thing, I'm going to go ahead and graph the first one, and I like to, on this one, use lots of colors. So I'm going to use purple for this first one. I'm going to use the part without the x first, so I'm going to start at 3. And then from there, since the slope is negative 2, I'm going to go down 2 over 1, down 2 over 1, down 2 over 1, down 2 over 1. And when I connect it, I need to make sure that I make a dashed line because there's no equal sign underneath. So we have to remember our inequalities on this one. And then if you recall, when it's an inequality, we're going to shade one side or the other. So if you recall, we're going to test 0, 0. So let's test 0, 0 on this one. When I do that, if I plug 0 in, I end up getting 0 is bigger than negative 3. Oops, is that plus 3? Positive 3, sorry about that. Okay, so now we need to think, does the mouth eat the bigger number? No, it does not. This is a false statement. So we are not going to shade the side of the line with 0, 0. We're going to shade the other side, and it will be important that we do shade as much of it as we can. All right, and now I'm going to switch colors. I'm going with green on the second one. All right, so this next one, again, I'm going to start with the one that doesn't have the x in it, which was negative 4, so I'm going to start down at negative 4. And then I'm going to, since the slope is 2, I'm going to go up 2 over 1, up 2 over 1, up 2 over 1. It's kind of getting hard to see. I'm going to connect it with a solid line because there is an equal sign, so we do get to include it in our solution. And then...
Ready.
Okay.
I felt like I was checking for lockdown here.
Alright, so now again we get to test 0, 0, and when we do that, if I plug 0 into both of those places, I'm going to get 0 is less than or equal to negative 4. Is the mouth eating the bigger number? Nope, so this is also false, so I'm not going to shade my green line now. I'm not going to shade the side that has 0, 0. I'm going to shade the other side. Okay, and now we need a third color, a darker color. So here we go. My darker color is going to be, where do you see both colors? Where did both colors intersect? And it's going to be in this area right here. So that's what I'm going to take. You might want to like use your pencil or something for that part. Okay, and I'm going to also just darken the boundary line. This boundary line is solid, and this boundary line is dashed. So that is my answer right there. And then just like we did on the other inequalities, I'm going to put a couple that are solutions and then a couple that are not solutions. Okay, is a solution would be anything in this black area. So an example might be like 6, 2. It's for sure one. Another one that might be would be 4, 0. And then any ones that are not, anything that's not in this black area, so I'm just going to pick one way over here, which would be negative 4, 0. But I could also pick one down here, so I could pick 3, negative 4, because it's in the green, but it's not in my black area. So that's, lots of different things can be answers, so that's how you would do a problem that looks like that. All right, problem number 2, 3x plus 2y, we're going to make that less than 6. And then y is greater than negative 1. So we want to go ahead and graph these. We'll do each of them separately. So 3x plus 2y is less than 6. If you recall, this is a problem. If you're good at solving that for y, go right ahead, but most people like to write it 2 times. And again, we're just ignoring the less than sign for right now. We'll scribble off the y and scribble off the x. So to get x by itself, we'll divide both sides by 3. We'll get x equals 2. And then to solve for y, we'll divide both sides by 2, and we get y equals 3. So this means the graph hits the x-axis at 2, and it hits the y-axis up at 3. And there is no equal sign, so we're going to make a dashed line. Whoops. Try to get a little bit better than that. Okay. And then we do get to test the point 0, 0. Which is right here, right back up into the original function. So if I do that, 0 plus 0 will give me 0, 0 less than 6. Is that a true statement? Yes, it is a true statement. So I'm going to shade the side of the line that has the 0, 0 on it. Okay, now I'm going to switch colors. I've got y is greater than negative 1, so we're just going to be treating this as if it were y equals negative 1. The y-axis is vertical, so a y equals line is going to be horizontal at y equals negative 1. There is no equal sign, which means once again we will make a dashed line. Okay, and then if I test 0, 0, there's only one place to plug 0 in. I get 0 is bigger than negative 1. That is a true statement. So I will shade the side of the line that has 0, 0 on it. And now the last thing that we want to do is just look for where do I have both colors shaded in. It's going to be in this triangular region right here. So I'm going to first of all make my lines a little bit more solid here. And then it's going to be this region right here. So that would be my answer for that one. All right, next example, I'm going to, after I fill in this number, I'm going to let you go ahead and do this one and see how you do. So let's go ahead and put a 4 in there. So please, at this point in time, pause the video, try it, and then come back and see how you did. All right, I'm going to start up at 4. So starting up at 4, and then negative 5 halves is my steps over there. So I'm going to go down 5 and over 2. Down 5 and over 2. This is going to be a solid line because of the equal sign. And then when I test 0, 0, I get 0 is less than or equal to 4. That is a true statement. So I get to shade the side of the line that has the 0, 0 on it. I'm going to do lots of shading here. Switch my colors. Okay, green, here we go. This one I'll start down at negative 2. Kind of hard to see sometimes with these colors going on. I'm going to go up 1 over 2, up 1 over 2, up 1 over 2. It's going to be a dashed line because there's no equal sign. Okay, I get to test 0, 0 once again. And when we do that, I'm going to get 0 is greater than negative 2. Is the mouth eating the bigger number? Yes, it is. So this is also a true statement. So again, we'll shade the side.
Brandy Q, please come to the front office. Brandy Q to the front office.
We'll shade the side that has the 0, 0 on it, and then it's time to get my dark color. And so now I get to shade that area that where those two colors intersect, which again is just in this big slice right here. And I do need to shade the boundary areas. This one is a solid line, and this one was a dashed line. Okay, and then if we do an is and an is not, an is would be negative 5, 0, and an is not. I'm going to come up here this time. Let's do like 4, 4 is definitely not. And we will just save example 4. We might do it together as a class. So hopefully now you know how to solve a system of inequalities by graphing.